Hey, Nick again here with math and money. And in today's lesson, we're going to dive deep into the math of simple interest versus compound interest. And this aligns with linear equations versus exponential equations. So here, simple interest is just where you make money and you're not using compound interest, meaning you're just earning your interest is what your rate of return is on your principal. And then you multiply it by the rate times the principal times the amount of time you have it. And then you just add it back to your initial principal. So, for example, let's say you have a $10,000 in your account, right? This is basically your y-intercept, right? If you're familiar with algebra, we have this formula called y equals mx plus b, right? And this is a linear equation. It's a straight line because you're just taking your initial amount and you're adding a constant slope or constant rate. So here, if your amount that you have in your account is equal to the principal, which is how much you start off with, your initial deposit or your y-intercept of 10,000, right? This is what B is equal to, plus your rate, your interest rate. So your interest rate is basically what your principal times your rate times the T is your time. So here, if you have 10,000 and let's say you earn 10% interest rate, right? So if you're earning a 10% interest rate on your account, well, what's 10% of $1,000? Well, 10% of $1,000 is going to, or $10,000, I mean, because that's your principal, that is equal to $1,000, right? So that is basically what your rate is. You're making $1,000 for every year that you have in the account. So R stands for your interest rate, T stands for time in years. So let me go over into Desmos and show you what that actually looks like on a graph. So here is the formula. Y is equal to, you're going to make $1,000 or 10% interest of your 10,000, right? 10% of 10,000 is $1,000 every year. X is going to represent how many years. So if I just plot this here, let me just start over here. Here, I'm just going to. So let's say you start off with $10,000. So you have $10,000, and after year one, if you plug in one here for your variable, well, 1,000 times one is 1,000 plus 10 is 11,000. Now you plug in two, well, two times 1,000 is 2,000 plus your initial amount. That's 12,000. So at the end of year three, you have 13. At the end of year four, you have 14. And so this is just a straight linear equation, right? Because you can see this is a straight line. Your y-intercept here is at 10,000, and it's just going straight in a straight line. This is the formula for simple interest. Y is equal to your interest that you earn times the T plus your initial amount. Now, let's go over to compound interest. Compound interest is an exponential function, meaning here, instead of mx plus b, now you could see your time is in the exponent. And the reason this is because if you think about it, it makes sense intuitively, right? Let's say you have $10,000 in your account. Well, interest or compound interest is basically after year one, it's going to be the same thing, right? Because one plus a 10% rate of return. So one plus a rate of 10% is 0.10. So if we do that, that's just 10,000, right? And you multiply that by 1.1. So anytime you multiply by a number greater than 1, the decimal after is what it's growing by. It's growing by 10%. So what does that give you? So here, if we put it into the formula here, right? 10,000 times 1.10, right? If X is 0, anything to the 0 power is just 1. So that's why you get 10,000. But if you put 1 in here, well, you have 1.1 times 10,000 gives you 11,000. You'll notice it's the exact same thing in the simple interest formula. Where this starts to get interesting is when now you have 2 years. So let's put 2 instead of 12,000. Now we have 12,100. Why is that the case? Why are we making an extra $100 versus just 12,000? Well, it's actually pretty simple, because if we look at this formula, right? T, now your time is 2 years. That's the same thing as doing this, 10,000. But you're multiplying it by 1.10, right? Which is equal to what? We said 11,000. But now, because you have your principal is now bigger, now you have 11,000, but now you're earning 10%, right? Which is another 1.10. You multiply 10% of 11,000, not 10,000. So that is equal to 12,100, right? Now you take this amount and you multiply it by another. Actually, that's not 11,000. I take that back. I'm sorry. That is supposed to be 11,000, right? So after year 1, you make 11,000. After year 2, you make 12,100, because you're taking 11,000 and you're multiplying it. I apologize for that. I'm trying to get my math right here. So here, this is what you do. So T here is equal to 2. So what happens is you take your $10,000, right? And you multiply it by 1.10, right? So if you do that, you're going to get 11,000. But whatever this answer is, you multiply it again by another 10%, because you're earning 10% on top of that. So if you do it for 3 years, you're going to multiply whatever that answer is, which is 12,100, and you're going to multiply that by another 1.10, because it's growing by 10%. This is the power of compound interest, right? Because instead of just adding a constant rate, your rate of change is going up by 10% more every time. And that's where you get this formula right here. Raised to the X or the T, this stands for time. You're just multiplying it by 10% more of the previous amount, right? So if you do it for another year, you just take that and you multiply it by another 10%. Right? Because anything multiplied by 1 is just itself. But if you multiply it by a number greater than 1.1, that means it's growing by 10%. So here, if you put in your numbers here, right? 3, you now got 13,310 versus just 13,000. And then we put in 4, 5, 6, 7, 8, 9, 10, right? And this is how you can really get your money to grow, because here, if you do up to 10 years in simple interest, you only have $20,000, right? Because your money is only growing by $1,000 every time, right? Because in year 10, you plug in 10 here for X, right? You put in 10, right? You just multiply, well, 10 times 1,000 is equal to 10,000. And then you add that to the initial principal, which is 10,000. That's how we get 20,000 here, right? Because you're just adding 1,000 every time. But if you use compound interest, where now it's growing. Your interest is earning interest, right? So basically, you take your amounts, and the first year is going to be the same, but now you're taking 10% of this amount, which gives you 12,100. Now you're multiplying this 12,100 times 10%, which gives you that amount, because you're now earning 10% off of your new amount versus just making 10% off of your original amount, which always gives you the same amount every time, right? This is growing. This is the power of compound return, because here now you have 25,000 versus 20,000 because your interest is earning interest on your new amount. Hopefully that makes a little bit of sense. I know this formula can be a little bit intimidating at first, but if you break it down, it's really not that complicated. You're just earning 10% of your new accumulated amount. So if I just here pull up a calculator here, right? Just so that you guys can see the math. You could just say, okay, well, right? If I go 12,100, so here I just go here. I don't like that calculator here. 12,100, right? Multiply that by 1, and we're growing it by 1%, equals 13,310. That's where you get this 13,110, because you're just multiplying this and it's growing by 10%, right? You're multiplied by 1.10. This is the growth rate. This 0.10 or 10% is the rate that you're being compounded by. And then if you just plug it into this formula here, you don't have to go one by one. You could just say, well, after 10 years, right, you just put in 10. So you go 10,000. Here, let's clear this out. You go 10,000, 1, 2, 3, times, or actually I don't even have to put time, just put parentheses, 1.1. And then you just put your exponent to the 10th power is 25,937, which is what you get here, 25,937. So this is just a shortcut, but this shows you how you can calculate it year by year. Or if you just know the formula, just plug it into the compound interest equation right here, where R is your interest rate, right? So let's say you're getting compounded at, instead of 10%, you're getting compounded at 12%. So that would be, right, 1.12, right? Because 1 plus 0.12 is 1.2, and then you just raise that to figure out after how many years. And then the P is your initial amount, right? $10,000, right? And then you'll see that this is going to grow faster. It's going to double, right? Your money's going to double. Divide, a quick way to do it is 72 divided by 12 is 6 years. So if you look here, your money is actually going to double every 6 years, right? So you have 10,000, right? After 6 years, right, you're going to get 20,000, right? See, that is the rule of 72 is just a quick way to do it, because here you're starting at year 0. That's why it's 10,000. So it actually takes you 6 years. 1, 2, 3, 4, 5, 6, 7. It's actually 6 because this is 0 here. So that is a quick way to just guesstimate using the rule of 72. But hopefully that kind of clears up where the compound interest formula comes from and how you use it to really grow your money exponentially versus just simple interest where you're just making a constant rate of change. Your slope is always the same, right? For every year you go up, you make $1,000, right? That's what rise over run, right? You rise $1,000 every 1 year, $1,000 every 1 year. Well, this graph here, this scale is not in the thousands, but basically here, if we zoom in really closely, you can see, right? For every $1,000 you go up. See, here's from 12,000 to 13,000. For every 1,000, for every year you go, right, from 2 to 3, you're going up $1,000. You go up 1,000 over 1 year. So you're going up 1,000 every year. So that's just quickly how you look at it on a graph. Your y-intercept on both of these is $10,000 because that's your initial amount that you're starting off with, your principal balance. And then it's just growing either using simple interest versus compound interest.